On the early morning of January 7, 2024, Beijing Aerospace City was rather busy in the cold winds. A large fleet of heavy-duty trucks was leaving China Academy of Space Technology in an orderly fashion. The fleet was carrying the subject of this video, Chang'e-6. Right now, it was dismantled in pieces that were carried in dedicated containers on those trucks. Despite the freezing temperatures outside, the climate in the containers was strictly controlled. Every container had its own independent power supply and climate control system. Those containers were headed to Hainan Island, where the temperature was over 30 degrees Celsius higher, and the fleet was going to the capital airport now.
Following the success of Chang'e-5, the key objectives for Chang'e-6 are to build upon the existing foundation, while making further enhancements and introducing innovations. Secondly, the new journey should get us new scientific findings. That is, the samples we get from the moon should give us more insights into the moon. Another thing is we are going international this time, to carry international payloads, so that we can explore together, to gain new insights and perspectives about the moon.
2 days later, at Haikou Meilon Airport, a dark gray plane flew in. Obviously it was not a passenger aircraft. It was the Fat Girl, China's domestically built large transport aircraft, Y-20, who transported probe Chang'e-6 to Hainan.
One, two, down. Stop.
We're all familiar with Wenchang Space Launch Site, 3 years ago. The Mars probe Tianwen-1 and the lunar probe Chang'e-5 departed from here one after another. The 3 modules of China Space Station were also launched from here. Now Chang'e-6 was here. It would start its assembling and commissioning, and complete all work necessary for the launch in the next 4 months. The target of this mission was the far side of the moon. The far side of the moon. Let's review this term. Be it full, gibbous, half, crescent, or whatever shape you see the moon is in. It doesn't change the fact you can't see its far side. It is because through the eons, the gravitational interaction between the Earth and the moon has made the moon tidally locked to the Earth, with only one side always facing the Earth, and the other side always hidden. On January 3, 2019, Chang'e-4 achieved mankind's first soft landing on the lunar far side. And this time, Chang'e-6 would visit that side again, and take back to Earth some soil from there, which would be mankind's first sample retrieving mission there. No one had ever done it before. Would things be different on that side?
The main differences between the two sides lie in their space environment and geology, which is called the lunar dichotomy. It means the far and the near side look so different even on pictures.
This is the most clear global image of the moon now. It's from the Chinese lunar exploration program. The near side shows dark and light areas, the former called Maria, the latter highlands. This is Mare Fecunditatis. In 2009, Chang'e-1 made a controlled landing here. Further ahead is Mare Tranquillitatis, where mankind first stepped on the moon. And then it is Mare Serenitatis, where the Soviet Union's Lunokhod 2 set a lunar driving record of 39 kilometers. Beyond the Montes Apenninus lies Mare Imbrium, where Chang'e-3 has been working here for over 10 years. To the west is Oceanus Procellarum. In 2020, Chang'e-5 took 1,731 grams of lunar soil from here. Obviously, the Maria are relatively flat. So far, most of mankind's moon landings and explorations happen on the Maria. Traversing Oceanus Procellarum, we reach the far side of the moon, where the terrain abruptly elevates, and the surface grows increasingly rugged, dotted with craters of all sizes, where finding a large, flat area is nearly impossible. The far side as a whole looks distinct from the near side.
The crust on the near side is thinner than on the far side, and is made of different stuff. Basalt makes up to 17% of the lunar surface, and is found mostly on the near side. There is very little basalt on the far side. What is found there is mostly highlands and orthosites. Why is there such a huge difference between the two hemispheres? This is a very important, top-tier scientific issue. We need samples from the far side to study directly. It is of vital significance to the research of the moon's formation and evolution.
The moon's evolution is about where the moon came from and how it became like this. There are many hypotheses about its origin. The co-accretion hypothesis believes that the Earth and the Moon are twins. In the nebula that gave birth to our solar system, the majority of the matter formed the Sun, while the remainder became the planets, including the Earth. The Moon and the Earth formed at the same time. According to the fission hypothesis, the Moon is the Earth's direct offspring. It split off from Earth. In its early days, the young and molten Earth rotated far more rapidly than it does now. During this rapid rotation, some of its mass was ejected, which eventually coalesced into the Moon. The resulting massive depression on Earth became what we now call the Pacific Ocean. The capture hypothesis proposes that the Moon was once an independent celestial body that was captured by Earth as it passed by. It was then taken hostage, orbiting Earth ever since. The impact hypothesis suggests that the early Earth was struck by a celestial body roughly the size of Mars. The immense energy from the collision transformed Earth into a molten, fiery sphere. The impact ejected trillions of tons of scorching debris, which were thrown into orbit around Earth. Due to its gravitational pull, the debris then collided, gathered together, and grew, much like a snowball, until it formed a new celestial body, the Moon. To figure out the Moon's origin, the best way is to take samples from the Moon and study them thoroughly. Chang'e-6 aims to accomplish mankind's first sampling from the lunar far side and return the samples to Earth. The so dedicated Chang'e-6 was now inside the largest testing facility at Wenchang Space Launch Site. The lander, the orbiter, the ascender, the return capsule, the support module, the docking mechanism, and other major parts were placed separately. In the coming days, they would be reassembled. To endure a temperature difference of over 300 degrees Celsius between the sunlit and shaded sides, the probe would be covered with a polyimide multilayer insulation film, which would give it a golden look. The orbiter is a transport between Earth and the Moon. The return capsule delivers the samples to Earth. The docking mechanism handles docking and sample transfer. The support module carries over 3 tons atop. The lander takes care of landing and sampling. The ascender takes lunar soil off the Moon. Apparently, the probe here looks brand new. But Chang'e-6 is quite special among spacecrafts, as it broke a record in spacecraft storage time. You should know, Chang'e-6 had been manufactured 8 years ago.
Would it still work? Time can change many things. Even something precisely assembled could deform under gravity. Also, for certain organic materials, some of their constituents might dissipate over time. Would this affect their performance? So, we need to break each product into its smallest units and analyze them to determine if they would still work. Let's take the 7,500 Newton landing engine as an example. It had been installed inside the probe. Could we dismantle it and replace parts? After much discussion, we decided to use a new engine.
As mentioned earlier, the lunar far side is never directly visible to us, meaning the Earth can't be seen from there either. Similarly, radio waves carrying instructions for landing, sampling, and takeoff from the lunar far side cannot be sent directly from Earth. We couldn't afford to lose control of the probe on the lunar far side. To maintain communication with Chang'e-4's lander and rover, which were operating there, the Chang'e relay satellite was launched on May 21, 2018, from Xichang Satellite Launch Center. It orbits above the lunar far side, like a reflecting mirror, establishing a two-way communication link between Earth and the Moon's far side. Could Chang'e-6 still use that satellite?
Chang'e was designed to last for 5 years and to serve for only 3 years. By the time of the Chang'e-6 mission, the satellite had already surpassed its lifespan, and its function was uncertain. So Chang'e-6 couldn't risk the mission on Chang'e.
In a testing facility at Wenchang Space Launch Site, Chang'e-2 relay satellite was being assembled. The task for the day was to install the relay antenna on top of the satellite and do the commissioning. At 9:40, the installation started. A crane lifted and slowly moved the antenna over the satellite. Soon, the antenna was properly placed. It was like a golden umbrella. Before the satellite was launched into orbit, the umbrella was usually folded. But today was different. After its installation, an unfolding test was conducted. The antenna's transmission terminal was wrapped inside the silver insulation at the tip. The canopy was made of molybdenum wire mesh, with a diameter of only 15 to 30 micrometers, about a quarter of the thickness of a human hair. It was gold-plated to enhance its reflection. Once unfolded, the umbrella was 4.2 meters in diameter, the same as the one on Chang'e launched in 2018. Today was the last time it was unfolded on ground.
The antenna is fixated on the satellite. It can't move on its own and relies on the satellite's controlled positioning to ensure it points accurately towards the probe on the Moon.
The assembly of Chang'e-2 continued. 2 days later, the satellite was moved to the other side of the facility. The installation of the solar wings would begin soon. Chang'e-6's solar wings were of a dual-fold design. Before installation, one side of the solar wing was unfolded and hung on a metal frame. The installation was straightforward, followed by a series of tests. The first test was the unfolding test. The hinges connecting the two panels on the solar wing contain springs. Like a wind-up mechanism, the springs are compressed when the solar wings are folded and release when they unfold, causing the panels to unfold instantly. The electrical test followed the mechanical one. Chang'e-6 operates at above 1000 watts. To ensure the power generated by the solar wings meets the satellite's needs, we need to have the solar wings receive sunlight as perpendicularly as possible.
Voltage is normal.
Got it.
At the base of the solar wing there was a single-axle rotation mechanism, which allowed for adjusting the wing's angle relative to the sun. So, who controls its rotation? It was the sun sensor. It helps the satellite in orbit find the sun at any time, and drives the motor to control the solar wing's angle to the sun. At the same time, the assembly of Chang'e-6 was also in progress. The orbiter was a big cylinder of 3.1 meters in diameter. The solar wings were already installed on both sides. It was equipped with attitude control engines of varied sizes, as well as a rotatable directional antenna, and several rod antennas for communication. Above the orbiter, the return capsule was in place. Around the capsule was the white docking mechanism, with 3 pairs of metal docking claws at the top, which were interlocked like a clasped handshake at the moment.
It has a thermal control coating on the exterior, and uses mostly strong, lightweight materials like carbon fiber in honeycomb sandwich structure. We use them on the orbiter to reduce its weight.
For spacecrafts, weight reduction is always a priority. Inside the orbiter, in addition to various equipment, there were 4 spherical fuel tanks with a diameter of 1.1 meters each. And amid the 4 tanks was the 3,000 Newton main engine. All of these weighed only 1,200 kilograms. But once the tanks were filled with fuel, the total weight would reach 4 tons.
We use a carbon fiber shell with 4 pits in it to house the tanks. This way, it remains light while still being able to handle its weight, and it occupies minimal space. Now, the orbiter appears not very tall, but it carries a lot inside. It's quite compact inside.
On March 5th, Chang'e-6 completed its assembly and was moved to the fairing facility. Today, it would be placed on the launch support structure at the tip of the rocket, followed by installation of the fairing. On one side of the satellite, a folded mechanical arm was installed, with a small planar disc antenna at one end.
We also have a 0.6 meter, 2-dimensional deployable planar antenna. We perform real-time calculations. Based on locations of the satellite and the ground station's position, we can compute such data, so that the antenna can simultaneously point to the moon and the ground station.
This antenna would transmit signals to the ground. Data acquired by Chang'e-6 on the moon, and images captured by its cameras, are transmitted to Earth through this antenna once received by Chang'e-6. The fairing was 12 meters tall and 4.2 meters in diameter. After installation, it would protect the satellite until it exited Earth's atmosphere. Once a satellite or probe is installed in place, it means that soon, it will depart for a distant, strange world.
I don't want it to leave. I'd never see it again. This is the last time for me to see it as a whole. Soon, I'll never see the whole thing again.
Long March 8 Yao-3 carrier rocket was 50.3 meters tall. It was a 2.5 stage rocket. The first stage was 3.35 meters in diameter, carrying two YF-100 liquid oxygen kerosene engines, just like Long March 7. The second stage was 3 meters in diameter and used the third stage from Long March 3A. The two 2.25 meter diameter boosters could also be found on Long March 7. This modular design approach combines several mature modules to create a new product, which saves time in R&D and reduces costs. On the early morning of March 20th, Long March 8 Yao-3 carrier rocket stood tall on the launch pad. This was Long March 8's third mission and its first moon-related mission.
20 seconds.
The sky was brightening and the clouds were low.
5, 4, 3, 2, 1. Lift off.
At 8:31:50 seconds, the rocket soared into the clouds. "24 minutes later, the satellite and the rocket separated, and Chang'e-6 flew towards space. 50 seconds later, its solar wings spread, followed by the unfolding of the golden umbrella.
I see the relay satellite Chang'e-2 as a stage setter. Once the stage is set, Chang'e-6, Chang'e-7, and Chang'e-8 can put on their fascinating shows on it in the future."
The assembly of Chang'e-6 was also concluding. For this mission, Chang'e-6 carried 4 international payloads in collaboration with other countries. On the front side of the lander was a gadget. The negative ions at the Lunar Surface Instrument from ESA. What are negative ions? Middle school physics teaches us, the nucleus carries a positive charge, while electrons around the nucleus carry a negative charge. When an atom is exposed to high-energy solar winds, it gains a lot of energy. Some of its electrons may break free from the nucleus. At this point, the nucleus becomes a positive ion. The freed electrons might attach to normal atoms to form negative ions. Why measure negative ions on the lunar surface?
One day, we will send people to the moon again, and this research would tell us if an electrostatic field that would affect human activity exists there, and what is the ion environment like there. Such information is important for safeguarding probe equipment and human health.
On the other side of the lander was the detection of outgassing radon from France. According to middle school chemistry, radon is a noble gas that is radioactive.
After landing on the moon, we have 48 hours to measure this radioactive gas of trace amount. But that's not the end of the story. We are also interested in the lunar soil samples to be taken back to Earth. We want to study the samples in laboratory and compare the results with Dorn's findings on the lunar surface.
On the top side of the lander was the Italian laser retroreflector. And the orbiter carried Pakistan's Cube satellite. It was not the first time China's moon exploration mission carried international scientific instrument. Chang'e-4 also carried on its mission 4 international instruments. China's lunar exploration is open to worldwide scientists.
As a European scientist, I'd say Europe has yet to develop its capability to deploy equipment on the moon. Many countries are now interested in the moon, so I believe this mission has built a good environment for different countries and scientists to work together.
I would hope so. Eventually, mankind, as a species, will become stronger, working together and seeking common goals. Every international collaboration we strive to succeed in now is another little link in that journey to that future.
The moon, a planetary body keeping our company, attracts the whole world's attention. To scientists, it is beautiful and a treasure in science, awaiting mankind's exploration. Chang'e-6 was now all set to go. Soon, it shall carry the dreams of worldwide scientists on its journey to the moon.
个究竟，眼前是满天烁烁繁星，身后是地球美景，带着未来的憧憬，奔月的道路上留下你坚强的背影。